be part 4, lecture 15. Symmetry, necessary condition for Noether theorem. So Noether theorem you derive based on the assumption that the system it has symmetries. Why? Because in Noether theorem links the structure of the symmetries to these physical quantities that in this case that must be conserved. If the system does not possess a symmetry, Noether theorem does not provide any conserved quantity. That's important. For example, translation symmetry leads to conservation of momentum. Rotation symmetry leads to conservation of angular momentum. And also recall that Lagrangian L and Hamiltonian H are fields. Okay, they are described using Eulerian viewpoint, as we emphasized in previous videos. In general, application of Noether theorem, symmetry must be identified before. That's important here, which is written just over here. So in the special relativity, the Lorentz transformation presents a space-time symmetry. It leads to the conservation of angular momentum. Later we will see these properties. See, that's and also special relative will be a subject that we will treat later. Okay, but that's a very important remark about the use, the application of Noether theorem, in which symmetry is a necessary condition. Okay, that's what I would like to emphasize on this lecture.